Hey everyone, welcome back to another video by Camroom 5. In today's video, we're going to be starting with a new concept which is known as entropy. Now, it's one of the most misunderstood concepts in physics and chemistry, or rather I should say one of the most tricky yet interesting concepts in thermodynamics, which obviously includes physics and chemistry both. Since it's a very unique concept, first we are going to be discussing an example to see what entropy is. Let's imagine a very highly magnified atomic scale of two crystal lattices. So crystal lattice A and there's a crystal lattice B. Both have 4 slots. You can expect atoms or ions or whatever in those slots. Now crystal lattice A has less energy. So when I say less energy, I refer that it has only, let's suppose, 1 photon of energy. So it has only 1 photon of energy absorbed by it. But crystal lattice B had more energy. So it had more energy, which means that it had absorbed apparently 2 photons of energy. Now let's talk about the possibilities of those energy values. Which slot will have the photon? So I'm going to be talking about the possibilities of those photons. When I talk about that, the first possibility is that slot number 1 has the photon. So first possibility is slot number 1 has it. The second possibility is slot number 2 has it, because there's only 1 photon, so it could be either 1 or 2. The third possibility is slot number 3 has it, and the fourth possibility after slot 3 is that the fourth slot has it. There's no other possible way. Only 4 possibilities. Only 4 possibilities. But when I talk about crystal lattice B, it can have the photon in the first and second slot simultaneously because it has 2 photons. So based on the possibilities, I got slot number 1 and 2 both have it. Let's remove these from here, and the second possibility is first and third slot has it at the same time. So another possibility is number 1 and 3. The third possibility is, let's suppose 1 and 4 has it. So there's another possibility, 1 and 4 has it. Then there's a possibility that 2 and 3 has it at the same time. So new possibility comes in when slot number 2 and slot number 3 has it. Or it could be slot number 2 and 4 at the same time. So there's a new possibility 2 and 4. Or the last possibility is slot number 3 and 4 have 1 photon each at the same time. So it could be 3 and 4. When you count that, it has 6 possibilities. With more energy, you have more and more possibilities of energy dissipation. Now going back to the definition, entropy means that it's a measure of basically the disorderness within a system. When there are more chances of more and more possibilities, it means there's more and more entropy. So when energy gets more and more chances of dissipating itself, dispersing itself, spreading itself, it is called more and more entropy. So another definition is, it is a measure of dispersal of energy. It's a measure of dispersal of energy within a system, at specific temperature. So more entropy means energy gets more chances of dissipating itself and spreading itself, but less entropy means the substance doesn't have energy, so obviously it can't spread. Now let's move on to a concept of standard entropy. Let's move to the concept of standard entropy, which is denoted by this symbol. So when we talk about standard entropy, what actually it means is, it's a hypothetical scenario where a substance was At 0 Kelvin temperature, which means literally zero energy, at 0 Kelvin temperature, which is known as the absolute zero, and it was in a perfect crystal structure, so it had no disorderness in the structure. And then when it moved to the state at standard temperature pressure, now the substance has moved to the state at standard temperature and pressure. This is the standard entropy of the substance. Now whatever entropy this substance has at standard temperature and pressure, this is known as the standard entropy of the substance. And it is never zero. It is never a zero value, because every substance has at least some entropy. With that, let's move on to a new concept which is known as change in entropy, or you can say change in entropy at standard conditions. So it is basically the change in entropy during a reaction. It is all about a reaction happening. So it's the change in entropy during a reaction at standard conditions. The change in entropy for a reaction can be two possible values. The change in entropy could be a positive value, or the change in entropy could be a negative value for a certain reaction. A change in entropy being positive means that entropy is increasing, which means it is resulting in more randomness, more chances for the energy to spread away. Negative entropy means that the entropy is decreasing, which means that the randomness, or you can say the disorderness, is decreasing. So less randomness and less chances for the particles to move in a random direction in a disorderliness manner. For example, when calcium carbonate absorbs heat and becomes calcium oxide and carbon dioxide, it is basically a solid turning into a gas. It's a solid, which is calcium carbonate, turning into a gas. Solid has a more crystalline structure, it has a more fixed pattern of structure, but gas is more and more dissipated. So as carbon dioxide is made, the energy can be spreaded more in the carbon dioxide particles because they are randomly moving. So as a result, the entropy is positive because there's a conversion from solid to gas, and gas allows more randomness and more chances for the energy to be spread. So more chances for energy dispersal. Another example could be when nitrogen and 3 moles of hydrogen combine to give you 2 moles ammonia. You can see they are both gases, but on the left hand side there are 4 mole gases, but on the right side there are 2 mole gases. So the amount of gaseous mole is decreasing. You can say amount of gaseous moles is decreasing, which means previously there were more and more gas particles, but now they are less. So less chances for energy to spread away because the amount of gas is decreasing. So less chances for energy dispersal and less disorderliness, less randomness. So here the entropy in the second example would be negative. So far we have talked about what entropy is. We have talked about what standard entropy, which means the entropy of a substance at standard temperature and pressure. We talked about the symbol, which is S, and we talked about change in entropy, which means the change in entropy during a reaction. We said that entropy changes could be positive or negative. Positive entropy means more and more gas is produced, so more chances of random disorderness. And negative entropy means that entropy is decreasing because the amount of gas moles are decreasing as the reaction goes on. I hope the basic idea is clear. In the next video, we'll do some past paper questions. Stay tuned, guys. Thanks.